Hello guys, welcome back to my YouTube channel. Today I am going to solve day 28 problem of this month on LeetCode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So this is LeetCode problem number 513, in which we have to find the bottom left tree value. Okay, so in this problem we have given the root of a binary tree and we have to return the leftmost value in the last row. Leftmost value, last row. Okay, so this is example 1. So here, what is the last row? So this is the last row, 1 and 3 the other last row. And what is the leftmost value? Leftmost value is nothing, 1. Okay, so this one is the output. In this example 2, what is the last what is our last row? So our last row is this 7, right? This is the last row. This is one row, this is second row, this is third row. Okay, so this one is the last row. And what is the leftmost element of this last row? So leftmost value is nothing but 7. So 7 is our output. Okay, so to solve this problem we can solve it using DFS or BFS, but in today's solution I'm just going to show how we can solve this problem using DFS, depth first search. Okay, so here this 2 is present, is our root, right? It is our root. So at this point what is the max depth? So at this point let our max depth is 0. Okay, when I move one level down from 2 to 1, then my max depth is 1. Okay, because this is one level. So I am going to calculate the depth from my root of a particular node. So for this 2 the depth is 0, for this 1 depth is 1, for this 3 depth is 1. Okay, whenever I encounter the max depth, okay, so initially depth is 0, after that my depth becomes 1 for both these. So whenever I encounter the max depth, I am going to return the left value which we are going to access first. Okay, so in this function, let's say this is a function given to us. Okay, so let's create one DFS method here. Let's call for a DFS method. Okay, and in this DFS method I am going to pass my root, and initially I have told you that the depth of my root is nothing but 0. Okay, so this is I am calling this function DFS, and initially let's take two variables. Okay, so let's create one int max depth. Initially by default let's take some minimum value. So max depth minimum value, let's take it as -1. Okay, initially this value is -1, and we have to return the value. Okay, we have to return the leftmost value. So let's store this value in our result. Okay, so this is my result. Here I am going to store the value. So in this function, in this method, I am going to call for this method, and I am hoping that this method is going to give me my result. So I am just going to return a result here. Okay, so this is done. Now let's define this. Okay, so let's create one private void DFS, and in this DFS I am going to pass my root. I am passing my root and I am passing the depth. Okay, so I am calculating the depth as well. So initially for root the depth is 0, I have passed 0. Okay, so let's say if my root is null. If my root is null, then in that case I have to return nothing, right? If my root is equal to null, then in that case I have to just return. Okay, this is a base condition if my root is null. Okay, and also initially we took this max depth as -1, but for root I am passing the depth as 0. So this depth is greater than my max depth, right? So if my depth is greater than my max depth, then in that case I have to update my max depth with nothing but depth only, right? So this is my new depth, and in the result I have to pass this value. So let's say if only root is available, this 2 is only available, then I am getting the max depth 0. Okay, if this is the case, then max depth becomes 0 only. Let's take this 1 and 3 are not available, only 2 is there. Okay, so max depth become depth, that is 0, and the result, in the result I have to pass the value of this root only, right? So can I write it like this, root.val? Okay, so this is done. Now in the end I have to check for the right and left and right values. Okay, so first let's check for left. so root dot left, and if I move to my left, so definitely one edge will come, right? So I have to increase my depth by 1. Okay, so that is the reason I am passing depth plus 1 here when searching for root dot left. And when I'm going to call for right, so dfs root dot right, again I have to increment the depth with 1. Okay, so this is done. Now let's run our code. So all the test cases has been passed. Now let me submit it. So our solution is accepted and the runtime is also good, 0 millisecond, and it beats 100% of users in Java. So I hope that you guys are clear with today's problem. If you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.